Okay, so now I'm going to teach you one practical use in the real world of doing what we just did in the last video with definite integrals. Also, I want to mention that I accidentally skipped a concept known as Riemann sums. I talked it with like the approximating integrals. But typically, when you're learning calculus, you don't do what I just taught you immediately, which is finding the exact area underneath a line. You usually start off by doing these approximations, and I'm going to teach you that in the last video for this unit and just like say once again that this is supposed to be earlier in the unit. It doesn't really matter, but it's basically you need to know how to do it, and it should have been taught earlier, but I forgot. So I'll just do it next. But anyway, so right now I'm going to teach you a practical use of this. So as we talked about before, when talking about distance, you would measure that in meters, right? And you would measure the graph, and this is the meters that you've traveled, and this is the time, right? And then we talked about how because the derivative is the line of the slope, then the derivative of this would be the slope of this, which would be m over t, or meters per second, which is like a velocity. And that's why velocity is the derivative of position. And then you could do that again to get that acceleration is the derivative of velocity, which is the derivative of position. Well, that's going to kind of come back to haunt you a little bit, because we already did a video on position and stuff, but that was with the indefinite integrals, and you just use that to find the equations. Well, now we're going to take that a step further and do that to actually find some useful information. One last thing I want to say before starting this video is there's a difference between these two words, displacement and distance traveled. Displacement is the distance from where you started. So, for example, if this is where you started, and then you ran 15 meters to the other side, and then you ran back, the displacement would equal 0 because the distance from where you started and ended is 0. But the total distance traveled, I'm going to write total dist, but its total distance traveled is going to be the 15 plus the 15 back, so that's 30. So that's the difference between displacement and total distance, is that the total distance is includes coming back, where the displacement is basically just the difference between where you started and where you ended, which in this case would just be 0. Okay, now that you know that, I'm going to teach you how you can actually find the displacement of a runner or an object over a certain period of time. So let's say, for example, that they tell you the velocity equation, VOT, is, I don't know, x squared minus 4. I don't know. So that means that every second the velocity is going up exponentially, and it started at -4, which means it started off going backwards. And what if it said find the total displacement from 0 to 4 seconds? Well, as we already discussed, the area underneath here is considered negative. So, as you know from, I should probably draw this a little better, but as you know from your algebra class that you had taken in the past, that this is going to start at -4, and it's going to have then an x-intercept at 2. So that means that it's going to be like right here. So we're trying to find this and this. These are not equal, by the way, so you're going to need to find the area underneath. Now the displacement would just be finding the integral from 0 to 4, because the displacement's going to be looking for you to subtract the -1, because you want to know how far you are from your original position. So you want to actually just do the integral of this. I feel like there's something else I wanted to say, but I cannot remember, so I'll just do this. So therefore, the distance from 0 to 4 seconds, x squared minus 4 dx. The reason you're using this line is because it's the velocity line, and the antiderivative is position, and we're looking for the change in position. Okay, so we're going to say, well, first off, the antiderivative of x squared minus 4 is x cubed with a 1/3 in front minus 4x. And so the answer to this would just be 1/3 x cubed minus 4x with the brackets around it. Remember this notation, 0 to 4. And then you could plug that in, and you would get what the distance traveled was. Or sorry, not the distance, I'm sorry. You'd get what the displacement was. Because this is minus 4x, it's going to subtract the area that it took when it came back. But, what if the question asks for the total distance traveled? So it doesn't just want to know how far you are from where you started. It wants to know how much you traveled in total. Well, unfortunately for us, this integral is not going to tell us that because it's going to subtract the negative 1. But what we can do is we can flip the negative 1 onto the top one, and the addition of these two, without not subtracting this one, but if you just added this one, if these were both positive and you add them together, then that would give you your total distance traveled. Luckily, we have a function in math that will make everything positive, and that function is known as an absolute value. So, to find the antiderivative of this, or sorry, to find the total distance traveled, you integral from 0 to 4 of absolute value d of t dt. In this case, that would be the x squared minus 4, right? Because we're not looking for the p of t, we're looking for the absolute value p of t. Now, we can't just take the antiderivative of this with the absolute values in it because we don't know how to do that. If you had a calculator, you could do that. But we're going to need to do something else because I don't know how to take the antiderivative of an absolute value. And I don't think you do because I taught you how to do that. So, let me just put in the x squared minus 4 here. What we're going to have to do instead is we're going to have to think about the algebra here. So, from 0 to, you have to know when is it going to go from negative to positive. Well, this is 0, this is 2, and this is 4. Then we know that 0 to 2 is going to be negative, and 2 to 4 is going to be positive. So because 2 to 4 is the positive part, we don't need to do anything to that, so we're just going to write a new integral from 2 to 4 with the x squared minus 4 dx in it. But how are we going to get this area underneath? Well, typically, the area, I shouldn't say typically, if the area underneath here is negative, but we want to get the positive part, then we'll just subtract the negative. So it'll be minus, and then the integral from 0 to 2. Do you see why? Because then you're going to get a negative answer, but you're subtracting the negative, so you're going to make it a positive. And now we can just evaluate this to get what the total distance traveled was. By the way, I just want to say one thing that I probably should have said in an earlier video. A property of integrals, which I should probably mention, is that you can actually flip the top and the bottom, and it'll make it negative. So what I mean is that if you have, just do it in terms of variables, a to b f of x dx, well, this actually equals the same thing as b to a, because you're going from the bottom one to the top one, so b to a f of x dx, if you put a negative symbol in the front. So a to b f of x dx equals the same thing as b to a negative, negative b to a f of x dx. And so that basically means that if you have a line right here, if you're going from 0 to 4, you would get a positive number, but if you went 4 to 0, it's actually going to get the complete negative. It's like you're subtracting this amount each time. You're not going to do that very often because it's easier to just, do what we just did and subtract the negative, make it positive, but just something I think you should know. So yeah.